this computer, and then we're going to go back and Nate, there you are. I will do slides.
Okay, thanks, Thomas. What's up, everybody? It's good to see you guys again. Hope you guys had a good break. Today's meeting is going to be Java reversing. I'm very excited for it because Java reversing has a special place in my heart. I started doing computer science by doing Minecraft shenanigans, you know, writing plugins and hacking around with that. So it'll be fun today. Let's get started. If you want to click next. This is the meeting flag for today. Hopefully you guys all know the drill, but if you're new, just go to ctf.sigpwny.com. Go ahead and type that string into the meeting flag and get 50 points for being here today. Give you guys just another couple seconds for that. Cool, let's get started. First announcements. So the last content meeting of the semester is this Sunday. It's going to be mobile hacking with Keith. You're not going to want to miss that. We're going to have some good content there. Then next Thursday will be just a social. So you don't want to do anything while we're all studying for finals.
I can cover it because I kind of just threw words up there if you want.
Go for it. Go for it.
All right. Hi. So we're nearing the end of the semester, which means we kind of need to start talking about next semester. So first big thing is UAE-CTF. Over winter break, we're going to do some UAE-CTF logistics stuff. So helpers, you know who you are. We're going to be bringing you into channels and just starting to get your opinions on, hey, like let's lock down a theme. Let's start doing challenges, all that stuff. And then research. We are going to be doing research again next semester. It's probably going to be through Professor Miller again. So if that's something that you want to do and pick up an extra credit hour, make sure to, you know, don't go too far over on credit hours and make sure to like allocate a reasonable amount of time. Again, it's 1 credit hour. You get to do some pretty cool like independent security related research project. That for those who are doing research right now, we're going to be meeting after this meeting. And then meetings, we need people to plan meetings. So next semester and the second semester, usually the first 2 or 3 weeks are like, usually the first 2 weeks is like, hey, this is what SIGPwny is, because there's people who like just started the semester again. And then we'll get, instead of like into tutorial stuff, we might do 1 tutorial meeting. We'll get into like the whack stuff. So like Windows environments, how to properly report vulnerabilities, 0-day mitigations, and like attack defense, stuff like that. Let's see, what else? Lastly, in terms of like admin, I don't know if a lot of you know, but I graduate from U of I in 2 weeks.
No.
I'm not gone. I am doing grad school here. So I will be here for just about another year. And I'll be here, but the next official person who's going to be in charge of SIGPwny is Nate, who's running this meeting. So big round of applause to Nate. Through the next semester, I'll probably have like a semi-administrative role. And you know, I'll still be the friendly face and I'll still be here. But Nate and I are going to start co-running things next semester. And by my last semester here, Nate will, you know, I'll still be here to help, but Nate will pretty much be running the ship. So congratulations, Nate. That's really it for the end of semester announcements, unless I can think of any. We're still doing the spray paint social. That may be next semester when it's warmer. So, all right, let's go.
Okay, sounds good. Let's get into it. All right, so I don't have an overview slide, but the stuff we're going to be talking about today mostly assumes that you're going to be able to decompile the Java. So I'm expecting in the near future, we're going to have a meeting about going into the specifics of the bytecode and more instrumentation on that. But for right now, it's going to be a pretty approachable meeting. Let's start at a high level. Maybe you guys are familiar with Java, maybe you guys aren't, but Java is a programming language. You compile it, and it becomes a .jar file, and that's the unit, that's the executable file that you're able to execute. You may be familiar with executable files on Linux when you have the typically extensionless file where you can just do ./executable and run it. On Windows, you might see .exe. This is the .jar is the equivalent in the Java. This file is literally just a zip file. That's exactly what it is. You can rename it to .zip and you can open it with any archival tool. What it contains is class files and metadata. And so what a class file is for every .java file that you write, you're going to compile that into a .class file, which has the bytecode or the instructions for the Java virtual machine. the metadata is going to be, really, you can just think about it as pointing to the .class file, which again is just the compiled.java file, where the main method is, so that the JVM knows which file to execute first. Just get the next slide. Oh, it's on your laptop. Sorry. Just to really drive the point home, I'm on Linux here, but you can do it on Windows too. You can probably just double click it on Windows. But what you do for all the challenges we have today, do java-jar, then the name of the jar. It will execute it. And then I just here demonstrating that you can in fact unzip the jar just like a zip file. And it has those things that we talked about. It has a .class, which is my main, and it has that manifest.mf, which is the metadata, which all that file contains is which class is the main, and in this case, it's main.class. So the good news about Java is that it is much easier to reverse than all the stuff we've been doing so far. All that x86 stuff that we've been doing with Ghidra and stuff that is extremely esoteric and complicated. Well, today's your lucky day because you don't have to do any of that anymore, typically. When it's not obfuscated, so in its default state, after it's been compiled, it is, I wouldn't say trivial, but it is extremely easy to just decompile that back into some Java source code, which looks exactly like this original source code that you've typed. So things which are kept inside of a .jar within the .class is the class name. So in x86, if you recall, we lost all variable information. Maybe we kept some function names, but like local variables and stuff, everything's just gone there. It's just replaced with registers typically, or stack variables. But in this case, you get to keep class names, function names, class variables, all the static and member fields. In fact, you even get to keep line numbers. And so this is useful for when the JVM crashes for some reason. You throw an exception here, you're unable to read a file or something like that. Then the JVM will print the stack trace, and it includes line numbers. And the only way you can do that is if you include some metadata about line numbers. In any case, having line numbers, like which bytecode instructions map to which line number in the original source file, makes it even easier to get the bytecode back to some sort of decompilation, which is amazingly accurate. The things you may not have in the compiled class file is local variable names, unfortunately, and any comments that you write in the Java source file, you will also lose in the compiled class file. So how do we decompile? So I want everybody to download this right now. Download bytecode viewer. Just go ahead and Google that. You can go ahead and type this in. We may have the slides posted. Do we, Chris, have the slides posted? Yeah, they're Club General. Okay, so go. Also, you can just download the slides in Club General. Click that link. You should be able to just follow that. This is a great tool because it combines several decompilers. So there's like 3 decompilers out there that are quite popular: Procyon, Fernflower, JD, GUI. I think was another popular one. What bytecode viewer does is it just combines all 3, and it allows you to select which one do you want. Because oftentimes the decompiler may get something, I wouldn't say wrong, but it may not be as intuitive as another decompiler. Maybe a decompiler is unable to decompile a function, or another decompiler will. So I encourage you to just download that, download a challenge from our CGFD, and just throw it in there. You can drag and drop it to the left side, and it will just pop everything up like this. And as you can see, it should look very familiar if you've seen Java before. There's nothing quite as esoteric as the stuff that we've been looking at with x86. I want to emphasize that bytecode viewer will be the most important tool for Java reversing. You will be able to solve Java reversing 1, 1.5, and 2, those challenges with just bytecode viewer alone. Okay, so from the perspective of the person writing the Java application, how can we prevent someone from trivially decompiling our code back into somewhat original source? And the solution to that is obfuscation, and that's what we all hate to hear. When we're solving CTF challenges, that there's some obfuscation. There's always obfuscation. But what obfuscators do is they, at a high level, an obfuscator takes some compiled, or maybe not compiled yet, code, and manipulates it in such a way such that the semantics and the behavior is consistent with the original. So the behavior is the exact same, but the code produced, or the executable code, is completely different in order to confuse somebody who's looking at it. So some common techniques is changing control flow. This may be, let's see, you can complicate Boolean expressions. I mean, you can add or true to expressions, and the branch will always be taken. But, then the decompiler will add an if true expression, and it doesn't make any sense. You can change the order of expressions and jump around to things so that there's not actually a perfect Java representation of what that bytecode expresses when you manipulate it in this way. So decompilers will fail to decompile it, and you're forced to look at the bytecode. You can rename classes, variables, and functions. This is a gimme. Everybody will do this. This is something that you cannot recover. So once they've renamed a class to A, right, instead of Minecraft.java, you're just going to have to guess that and rename it yourself. Variables and functions also lose their names. They often simplify it to a single letter. Not only does this save space in the final binary, but it also doesn't give you an obvious clue about what this class file does. They can remove and add functions. I don't know, some obfuscation techniques just off the top of my head. You can probably combine an entire .jar file into a single .class file with just one giant function with no two. So I don't see why that's not possible. So these sort of techniques make it extremely hard to reverse. Also very commonly in Java, is encrypt strings. So some very common popular commercial obfuscators, we'll look at those in a bit, like ZKM here, I have it listed, will encrypt strings using a common algorithm. And so deobfuscators will be written, which can just reverse that process. So the most important thing here is that an obfuscated Java file or jar can actually make it impossible to use a decompiler. The decompiler simply cannot read that bytecode and produce any sort of Java source which would have mapped to that same bytecode. And so what's necessary to combat this is to use a deobfuscator, right? So yeah, some people have been frustrated with this and they've implemented solutions for it. The pro strategy is to run the obfuscated jar through a deobfuscator and then put it through your decompiler and then get some good output from your decompiler, hopefully. And so this works great for commercial obfuscators. Those three that I listed before, ZKM, Aleatory, and some others. What this is able to do is able to fix control floats. It's able to remove those branches which are unconditionally true. And so it enables decompilers to sometimes still output good things, but you'll still never be able to recover the class variable or function names. I say that with a disclaimer actually, because there's been some work. Let's see, I know that there's been a company which decompiles some sort of like jars or APKs, which is like Android phone Java, basically. And they've been able to look at a function and use AI to give it a name. That's been pretty cool as well. So here is the deobfuscator, which I recommend for you all today. Java, the challenge 3, which I have on the CTFD, is obfuscated using ZKM. And so you're going to want to use this deobfuscator here, which is a deobfuscator for many of these commercial deobfuscators. And I also have a tutorial here in case you are stuck on that, because sometimes those tools can be pretty unintuitive. Let's look at an example of obfuscation, deobfuscation. So sorry for the low quality screenshots. I may or may not have just screenshotted this from the YouTube video I recorded 6 months ago. So on the left here, we have like a simple hello world that prints hello world 1, 2, 3, 4, 5. Here, when I run that through a commercial obfuscator called ZKM, it's going to say, let's take the main, let's introduce some like weird local variables. And you notice that hello world is missing from this program. I think that's the most important thing here. There's not too much logic that they could manipulate here super heavily, but obviously they did something because the decompiler interprets this now as a while instead of a for. So they probably removed the line numbers, right? So you couldn't understand that this loop was mapped up to these certain lines. And then here, this is called a static initializer right here. And so if you noticed that before in Java, a static initializer block here executes before everything, even before the constructor. It executes once for every class, or once every class that is instantiated does not reinitialize the static constructor, right? So it's one time for this class, which is different from a constructor, which runs one time for each class instantiated. I hope that distinction makes sense. It's hard to say in English. But in any case, I want to emphasize here that there's an encrypted string right there. It's hello world. This is classic. Whenever you see this, you must think ZKM. What you do is just run it through the deobfuscator and it will pop out. So that's good. It's easy to.
Okay, so today I learned that static initialization was a thing in Java.
Yeah, if you want,
What the hell?
if you want to look really fancy and get fired from your job.
Static.
Good question. Yeah. It's true in this case. Yes, they do know that because ZKM has not changed that for like 5 years, 10 years that it's existed. But in fact, you don't need to know ahead of time the encryption algorithm used or something like that for some obfuscator because you can observe it right here. So the screenshot's cut off, but the decryption routine, like the code which executes in order to map this and initialize C here to hello world from this string. I have just cut it off because it's long. But what you would have to do is go in there and look through it, see how it does it, reverse it, and then put that code there, the obfuscator. Does that kind of make sense? Yeah, so there's this kind of interesting principle where no matter how obfuscated it is, if the computer is able to map this to hello world during the duration of this code, surely we can write an algorithm which is the inverse. If it can execute that, then we can do it. That's not always true when it comes to hash functions, but in this case, it is. Good question. Any other questions? Okay, great. Let's go. Yeah, so that's going to get to you all the challenges except for the last one today. So bytecode viewer and that deobfuscator tool, right? When it comes to custom obfuscation, in CTS, you're always going to get custom obfuscation, really, except for very uninspired Java challenges. Basically, the first thing you do is see how far a regular deobfuscator can get you. Because even custom obfuscation will like to run their code through some sort of what we talked about earlier with the control flow obfuscation, right, where it changes all the if statements and while loops and puts go-tos in there and stuff to break the compiler. So anyway, put it through the obfuscator. Now they might have their own custom string encryption, right? You might have to go read through that and write the inverse of, or copy out the encryption code to map all the strings back. Here's a tool, here's a library. It's called Web Asm Library. This is what you can use to directly read and edit the bytecode in case that you need that, right? We've already spent a lot of time on this. It's going to be a huge time sink if you actually have to manipulate the bytecode yourself, right? If you're unable to decompile it. Wait, one second. One thing I want to say is that if you want examples about how this works, just go look at that open source deobfuscator, see how they use Web Asm, and use that to write your own. Last thing I want to say is that newer constructs from later JVM, JVM being the Java virtual machine, this instruction invoke dynamic have created opportunities for obfuscation techniques, which in no way, shape, or form map to decompilable code. So it's going to be really cool. I'm actually thinking about writing a challenge for it. So you'll see that soon. But here's an example of a Java challenge which used this invoke dynamic to just break decompilers. And it is a huge headache to reverse. Okay, that's all. Any questions for me? Do we all know where to get started with today's challenges? Bytecode viewer, open them up, bytecode viewer, deobfuscate, part 3. Okay, and then if there's no questions on that, this weekend, we talked about it, we're going to have mobile hacking with Pete. And then next Thursday, social at Murphy's. Okay, last slide, I think I just have some tips. Yep, so here's just some tips. Go look in the slides for links, and I'll be around to help. Cool, thanks guys.
Thank you, Nate.
Yeah.
All right. All right. Does anyone on Zoom have any questions? No? All right. Otherwise, I'm going to stop the recording. Thanks for a great semester, YouTube, to like the 2 or 3 people who are watching on YouTube, I guess. I don't know. Like and subscribe. We need to go viral on YouTube because then we can like actually get people and then they can make fun of me for having these cringe things at the end. All right, bye.